Welcome. Here we are at test corrections for Unit 3 test, angles and triangles. Great job motivating to get this done. I'm going to go through the whole test. The way to improve your grade on a learning target is if you scored lower than a 3, if you correct your question on your test, then look it over. Then you're going to rewrite it on the test corrections paper on the left-hand column, showing all your work, and then on the right-hand column, you'll explain how to do the problem. So, learning target 1 and 2. I also want you to write down what you're doing. So, write down, I can identify angle forms and find measures of angles when parallel lines are cut by a transversal. Remember, on these test corrections, fast forward if you don't need this learning target, and just move to the learning target you need. All right, here we go, going through all of them. So angle 1, I got to find for number 1. But I'm going to first write in 57 degrees because that's the information I'm given about this parallel line cut by a transversal. Angle 1 is supplemental to angle 3. So that means they add to 180. So if I just say 180 minus 57 degrees for angle 3, then in the calculator I can do that, or I can do it in my head, or whatever works best for you. That's 123 degrees. So I'm going to write that right here. And my justification is these two angles are adjacent to each other and supplemental. So that's how I figured that out. Then angle 2, it's 57 degrees. And when I look at that, I recognize they are congruent angles because they're vertical. And angle 4, it turns out, I don't have to know, but it would also be a vertical angle. Angle 6 for number 3, that's down here. And angle 6, that one's 57 degrees. And when I look at the relationship between angle 2 and angle 6, I see that those two correspond, which means they both occupy the same space between the transversal and the parallel line. They're on that upper right-hand side of it. And finally, angle 7, look at that, it's vertical to angle 6. So it is also a congruent angle. So those are the justifications, the relationships. Those are the measurements. You can find the measures of the angles between the parallel lines and the transversal. Now here we're going to add a little bit more, and we're going to solve for an equation. Here are two adjacent angles that are supplemental along a line. So that means I'm going to set up an equation, 20t for the first angle plus 5 plus 15, and that's so hard to see. Sorry that that was not printed out very well, but that is 15t as well. So 15t, and that equals 180. They're along that supplemental line. So now I'm just going to combine my like terms. 35t plus 5 equals 180, and I'm going to subtract 5 from both sides. That's going to zero out, and I'm going to have 175 35t. Divide both sides by 35 in your calculator, and then you're just going to get how many times that 35 goes into, whoops, hit clear there, 175 divided by 35, and that's going to equal 5 times. So my t, and all I had to do was solve for the given variable, t is 5. Now look at this. The relationship there is actually vertical. It's not a triangle, it's not 180. But that means they're congruent to one another. So this equation, I'm going to set up 3x equals, and that's a parentheses there. So that's going to be equal to 2x plus 16. And this is a pretty simple equation, because if I get the variables on the same side, when I do, I just end up with x, and I'm left with 16. So my answer is 16 degrees. So there's learning target 1 and 2. A lot of people missed this one thinking it was a triangle, and it's actually vertical angles that are set equal to one another. Excellent. Good job. I'm going to hide this piece right here. Okay, learning target 3. Really did a good job with this one. The only thing was just maybe some math mistakes. I can find the measures of interior angles of triangles. They equal 180 degrees. So 61 plus 58 plus x is going to be 180. You're just going to combine your 61 plus 58, and you're going to get 119 plus x equals 180. And then if you just subtract the 119 from each side, you're going to know that 180 minus 119 is equal to not 109. So 180 minus 119, 61 degrees. That's that first one. And this one gets a little more complicated with the equation we set up. Sorry, that was like a mistake there. That shouldn't have been there. And we're going to combine our individual numbers, and we are going to solve for x. So subtract 105 from each side. We'll have 3x equals, and we take 180 minus 105, and we're going to get 75. We break that up into 3 parts. X is 25. And finally, again, the 3 angles add to 180. And we'll just combine our like terms, 4 x's, 3 x's. That's a 2x. 3x, 51 plus 3x equals 180. We'll subtract the 51 from both sides. We'll be left with 3x equals, and you can check it in your calculator, right? Make sure you're getting it to the right place. 180 minus 51, it's going to be 129. And then if we divide 129 by 3, so we'll divide this by 3, this by 3, and we're going to get that that x is going to be equal to 43. Okay. So actually, it's not degrees, is it? It's just what the x is. You didn't have to find the angle on those. Okay, so justify why the sum of the interior angles of the triangles are always 180. When we cut out all 3 angles, if all 3 angles actually, I should probably say when all 3 angles are lined up, they form a line. The degree measure of a line is 180 degrees. So that's the reason that we proved, or that's how we proved, that all the angles are equal to 180 when you add them together. Okay. Then back here, this one was hard because we just forgot the way that this works. I can justify the relationship that exists between interior and exterior angle sums. So find the exterior angle of each triangle. The way we do that is the exterior angle is equal to the sum of the two remote angles. So we're going to say that this question mark is equal to, so this exterior angle is equal to 35 plus 95. So that exterior angle is going to be equal to 35 plus 95. When I add them together, it's 130. Now, a lot of people found out that they could do that by the 180 method. Find this piece, and then this would also be 180, and that was fine too. Here, 5x plus 10 equals 58. Sorry, these two added together equal this exterior angle. So we're going to add 5x plus 10 plus 58, and it's going to equal, it's getting pretty small there, 11x plus 2. So I'm going to have to combine some stuff here. 5x plus 68 equals 11x plus 2. That's an equation with variables on both sides. So I'm going to move my 5x over here. I'm going to get rid of it on that side. I'll be left with 68 equals 6x plus 2. And I'm going to subtract my 2 there, subtract it from 58, and I'm going to have 66, what am I saying, equals 6x. And then x, when I divide both sides by 6, equals 11. So that's my x, it's 11. And my exterior angle, if I put that in over here, 11 times x plus 2, 11 times 11 plus 2. 121 plus 2 gives me 123. So that's what the angle measure is. A lot of mistakes on that one. So just get those recopied down, then rewrite it in your test correction paper, and then explain how you do that. Okay, tell whether the triangles are similar. I can understand the concept of similar triangles. That means at least two angles have to be congruent. So we know triangles, when you add them all together, equal 180. We also know there's a 113 here, and there's a 113 here. So if I say 113 plus 22, I have 135, and whatever I add to 135, it's going to equal 180. So that's going to be 45 degrees. So right here, I'm going to have 45 degrees, and that tells me I have another angle that's the same. I only need two angles that are the same, because that means the third one is congruent. So they are similar because of the angles all being the same. And our last one, I can use indirect measurement to find measures of similar triangles. So write and solve a proportion to find the distance from point E to the lighthouse at point D. So E to D is what I'm trying to find, and I need a proportional relationship. You can write a lot of different ways. I'm going to say the x I'm trying to find, the long length, is to the 100, the short length, as the long length on the other triangle is to the short length. And so however you set it up, you're going to want to do cross products of 90 times 100 equals 36x. Cross products are equal in proportions. So we're going to do 90 times 100. We're going to have 9,000 equals 36x. I'm going to divide by 36 on both sides. Do that in my calculator. 9,000 divided by 36 equals No, I'm not going to do it by 6. I'm going to do it by 36. 9,000 divided by 36 equals 250. So my x, my missing part, is 250. And that's feet. Okay, write and solve a proportion to solve for x. Hard thing to see here is just you have a big triangle and a little triangle within it. So the long side of the big triangle to the bottom is to the long side to the bottom. But I'm gonna write x first just to pay attention to it. So the long side on the bottom is to the side, as the long side on the bottom is to the side. So the main thing is you have 120 cross products equals 15x. When you divide both sides by 15, x is going to be 8. So x equals 8, and it looks like we have centimeters for that. All right. So again, just fast forward through the parts that you need on this and get your test corrections turned in, and your grade will move up to a 3. If you want to have a 4, you'll have to retake the learning target. Okay, thank you so much. Good job.